Hi, this is Mr. Yates, teacher of Principles of Engineering at Patterson High School in Baltimore. Today we're going to look at how to take a vector, a diagonal vector like this one, and split it into its x component and its y component, and the trigonometric calculations that are involved therein. To begin with, let's review what a vector is. A vector is any quantity that has both magnitude and direction. In particular, this vector that you see here in front of you has a magnitude of 45 pounds force. That's the amount it has. And it has a direction of pointing sort of south-southeast, 62 degrees away from the horizontal. Magnitude and direction. Now, anytime you see a diagonal vector like this, you should immediately think to yourself, I need to split this up into its x and y components. Okay? So we're going to do that by drawing either a straight vertical line or a straight horizontal line to turn this vector into a right triangle. We could do a straight horizontal line right here from the arrowhead over, or I could do a straight vertical line from the arrowhead up to the x-axis. In this case, the vertical line up to the x-axis makes more sense because, as you see, the 62-degree angle noted will be included inside the right triangle in that case. So now we have, if this is force F, 45 pounds force on the diagonal there, we have split it up into its x component, Fx, and its y component, Fy. As you can see here, I have labeled Fx and Fy, as well as the main vector F itself. And I have also labeled the sides of this right triangle as opposite, adjacent, and hypotenuse. How do we figure those out? Well, the hypotenuse to me is always the easiest, because the hypotenuse is the longest side of any right triangle. And in particular, if we have a diagonal vector, the hypotenuse will be that vector itself. The legs of the right triangle, opposite and adjacent, will be the x and y components. After we figure out the hypotenuse, the next easiest for me is the opposite, because all I got to do is start at the angle, 62 degrees, and look what's furthest away from that angle. And in this case, it's the Fy component, the green side right here, that will be my opposite side. Adjacent is just a fancy word for next to, so that's also easy to figure out because it's the leg of the right triangle that's next to the marked angle, 62 degrees. To figure out the x and y components, I will eventually need to use both sine and cosine. So to begin with, I remind myself of the definition of sine. The sine of 62 degrees equals opposite over hypotenuse. That's just the definition of the ratio sine. 62 degrees, incidentally, just comes from the triangle. It is the marked angle that we have right here. Okay? Now let's look and find our opposite and our hypotenuse. Notice here I've circled the two relevant sides in calculating the sine. The opposite is Fy, and the hypotenuse we know has a value of 45 pounds force. So I'm just going to take those two values and plug them into this equation. Underneath opposite in the numerator of the fraction, I plug in Fy. Underneath hypotenuse in the denominator, I plug in 45 pounds force. Also, underneath sine of 62 degrees right here, I go to my calculator, make sure it is in degree mode, or I use an online trig table or a printed trig table to find sine of 62. How much is that? That's a known constant value. In this case, I look it up and find that it's 0.883, so I just plug that in underneath sine of 62. After doing these substitutions, what I have here is an equation with the variable Fy, so I want to solve that equation. To me, it helps to conceive of this as a proportion and just put the 0.883 over the number 1, because dividing by 1 doesn't change anything. And that way I can cross multiply. In particular, I cross multiply the Fy times the 1, following the red arrow, and that comes up with just Fy. I multiply 0.883 times 45 pounds force, following the green arrow, and 0.883 times 45 is about 39.73. and I bring down my equals sign. So I have right now Fy equals 39.73. I'm almost finished, but what I need is I need to verify the sign, as in positive or negative of this value, and I need to verify the units. Let's do the units first. The units are going to be the units we've been using throughout the problem, in this case, pounds force. So I will write pounds force next to that 39.73. To figure out if that's a positive or a negative 39.73 pounds force, I do need to look back at my picture. In this case, looking at the quadrant that this vector is in, it is pointing downwards in the y direction. If it were up, it would be up here. Downwards is a negative direction for Fy, so I do need a negative sign in front of that 39.73 pounds force. And there we go. I'm going to go ahead and write in negative 39.73 next to Fy. Okay, there it is in the triangle, negative 39.73 pounds force. And now we're done with Fy. We've solved for it. Now I need to go up here and do Fx, which is the adjacent side. Adjacent and hypotenuse, that is the cosine ratio. So I'm going to set up an equation involving my adjacent, Fx, and my hypotenuse, 45 pounds force. To set up the equation, first I just remind myself of what is cosine. Cosine of 62 degrees is adjacent over hypotenuse. I plug in from my calculator or trig table 0.469 for the cosine of 62 degrees. I do want to put that over 1 if I want to do any cross multiplying. My adjacent was back in the question. It was Vx or Fx if we're using the letter F for the force, divided by my hypotenuse, which was 45 pounds force. I cross multiply along the red arrow. Vx times 1 is just Vx. And I cross multiply along the green arrow. 0.469 times 45 is 21.13. I do need my units, which I write in right here, pounds force. And I do need a sign. In this case, although that might be a little unclear, a little messy, that's a positive sign because in the x direction, we're solving for Fx right now, this vector, this right triangle, is pointing towards the right. Left would be negative, right is positive. So we have that Fx is equal to positive 21.13 pounds force. And we have completed our vector problem. Thank you for watching, and good night.